Walk down the aisle of any modern grocery store, and you are surrounded by an illusion. The bright lights and vacuum-sealed packaging sell us the idea that human life is insulated from the raw, dangerous elements of the natural world. But our world is deeply interconnected. The barriers we build are porous, and unseen environmental hazards constantly bleed into the places we live, work, and eat. Our collective choices create new vulnerabilities. When we clear tropical forests for settlements or farms, we often create partially sunlit pools of water, ideal breeding sites for mosquitoes. In one part of Brazil's Amazon, a 5% loss of tree cover resulted in a 50% spike in local malaria rates. On a micro level, individual actions introduce potent chemical threats. In small-scale mining operations across the globe, workers use liquid mercury to separate gold from ore. When they heat the mixture, toxic mercury vapors are released directly into the air and soil. Passive safety is no longer enough. To protect ourselves, we must trace the exact pathways these biological and chemical enemies take to breach the human body. The most immediate threats are infectious diseases caused by pathogens. These living microorganisms, bacteria, viruses, and parasites, invade our tissues and multiply rapidly inside us. Take the biological pathway of malaria. A mosquito picks up the parasite from an infected person and passes it to the next person it bites. That parasite travels through the human bloodstream and multiplies inside the liver, where it begins destroying red blood cells. This single microscopic pathway currently puts almost half of the global population at risk. This map shows that the exposure is heavily concentrated in specific equatorial regions. In these areas of South America, Africa, and Asia, environmental conditions allow the disease to cycle through the population. But pathogens are moving targets. Mosquito species are becoming resistant to insecticides, and the parasites themselves are developing genetic resistance to the drugs we use to kill them. Biological hazards are actively evolving, searching for ways to bypass our medical and chemical defenses. Alongside living organisms, we face non-living chemical threats. Industry and manufacturing introduce carcinogens and mutagens that find entirely different routes into the human body. Heavy metals like mercury build up in water and soil, where they can convert into highly toxic methylmercury. This toxin biologically magnifies as it moves up the food chain, reaching its highest concentrations in apex predators like tuna and sharks. These medical scans show the physical consequences of that chemical pathway. The top two images display the severe tissue damage and brain shrinkage caused by mercury poisoning, compared directly to the healthy brain on the bottom. Other toxins are embedded in modern conveniences. Endocrine disruptors, like BPA and phthalates, are found in the hard and soft plastics we use every day, from food containers to children's toys. Once inside the body, these synthetic chemicals engage in biological sabotage. They can mimic or block natural hormones, attaching to our cellular receptors and interfering with growth, development, and reproduction. Chemical pathways exploit our daily consumption, turning everyday goods into stealth delivery mechanisms for toxins. By mapping these exposure pathways, we can engineer systemic roadblocks to interrupt the cycle. Basic behavioral interventions disrupt transmission at the source. Providing communities with inexpensive insecticide-treated bed nets and window screens physically blocks the biological pathway of the malaria parasite. Policy interventions provide a different kind of shield. Governments can regulate waste incineration to curb mercury emissions or ban specific phthalates from use in baby products. This graph shows the impact of these collective efforts. Between 1990 and 2017, the annual number of deaths among children under age 5 from infectious diseases fell from 6.5 million to 2.4 million. These shifts proved that environmental hazards are not insurmountable. When we understand the path a threat takes, we can build the infrastructure to block it. For the most vulnerable populations, we rely on human ingenuity. National Geographic explorer Dr. Hayat Sindhi develops low-cost medical diagnostics designed specifically for remote places that lack high-tech infrastructure. Her solution is a postage stamp-sized piece of paper, etched with microscopic channels and filled with diagnostic chemicals. A drop of blood travels through the channels, triggering a reaction. The paper changes color, providing a medical diagnosis in under a minute. This inexpensive tool allows health workers in isolated areas to monitor liver function for patients taking harsh medications to treat diseases like HIV or tuberculosis. We cannot fully sanitize the world around us, but by identifying these pathways of exposure and innovating specific tools to intercept them, we turn an invisible threat into a manageable risk.